Alright, so now we're going to look at our last type of equation here. We're going to look at problems that have a logarithm that you cannot just drop off like we did in the last problem that we did, where you have a log base 6 on both sides. Ones where you don't have the same logarithm base on both sides. So if you're looking at this guy right here, and you have log base 2 of x minus 4 equals 6, guys, just use the definition of a logarithm. Remember, this base raised to this exponent equals this number. So if you're looking at this, you take 2 raised to the 6th power equals x minus 4. Don't overcomplicate things when you're dealing with that. You've got the definition. 2 to the 6th power is 64. You take x minus 4 over here and you add the 4 to this side, you end up with 68 is equal to x. If the problem looks a little uglier and you've got some more stuff going on in the problem, just treat the rest of those parts of that problem just like you normally would in a normal equation. So you take this minus 2 right here in this guy and you add the 2 over to the 28. That ends up giving you 3 times the natural log of x plus 1 equals 30. Then you divide by the 3 to get the 3 out from in front of the logarithm, and then that gives you natural log of x plus 1 equals 10. Now technically I know some of you are thinking maybe you could take that 3 and you could move it inside to the exponent, and that is possible, but that would give you x plus 1 cubed, and you would end up making your equation a whole lot more difficult than you need to. Because once I get this logarithm by itself right here, then I am exactly the same type of skill that I'm using over here. This base raised to this exponent equals this number. Same thing over here, but what's the base, Mr. Harrison? Remember, that is base e, so it's e to the 10th power equals x plus 1. Now this one's going to be pretty ugly. You're going to subtract the 1 over, so you're going to have e to the 10th minus 1 equals x. If you need a decimal approximation for this, this one's going to be pretty ugly, because e to the 10th is going to be a pretty ugly answer. So you have to take out your calculator. Remember, the e is right here above the little ln key. And so you're going to hit second, and then you're going to hit that little ln button, and then you're going to take it and do e to the 10th power. Sorry about the bell there. And then you're going to do minus 1. Just be careful on the calculator. Make sure it's literally e to the 10th power minus 1. The yellow ones use that little exponent function for us. The black calculators, you'll have parentheses that you got to deal with. Press enter, and you can see that that's a pretty large answer there, 22,025.465, or 466, excuse me, when you round it. So don't hesitate to make sure that you realize that when you are dealing with these types of equations, the definition of the logarithm is going to be your key. So you've got to get that logarithm by itself, just like we did in both problems.